Hi, this is Darren Pulsifer, and today I'm talking about shifting to microservices to do development. So, when we first talk about this, let's take a look at what happens today. So, typically in developing applications, very simple. We start a project, we write code, we do local build and test, and then we check in the code into GitHub or whatever tool that you're using. And then typically continuous integration and delivery system kicks off, runs your team build, maybe checks your code into a repository that then kicks off things in a development environment. And then maybe you do build and test environment, and then eventually it gets into production. The key here is that we've got to progress the code through a local, through a dev integration area, and then into build and test, and then finally to production. Now, in the client server world, this kind of looks like this. The application is typically 2 or 3 tiers, a database, an application server, and maybe a web front end, right? So the developer is working on his part of the code. The other parts are stood up in his own environment or in the dev environment or a test or production environment, and he just makes his changes and checks in code and it propagates through. This is pretty well defined because we've been doing multi-tier development for the last 2 decades. So everyone's happy, everything works well. Well, in come microservices. Now, microservices, instead of having 3 different programs or services that I'm going to work with, now there are tens or 20 or even 100 different microservices that I'm going to use to start creating this application. And the benefits of microservices are huge, but there's also some costs. One of the costs is setting up the environment for each one of these different environments that you have, right? So on my laptop, I've got to be able to install the microservices on my laptop. In dev, they mean something else. In test, maybe I have additional services for performance testing or debugging and logging and all that stuff. And then in production, there's even more services. Maybe I need a high availability Mongo instead of just my one Mongo running on my laptop. So this really frustrates developers a lot. And I've talking to a lot of customers out there. What I found is that this migration between the different environments with microservices is extremely painful because developers, a lot of times they don't know all the caveats in using some of these tools, some of these services in production. Right? So we end up having fragile architectures, we end up having things that aren't very resilient. So our goal is to get to the same state that we were before with multi-tiered, where the developer's focusing on code and not environment, and then we know that the services that are available in each one of the environments are appropriate for that environment. So like on your local box, you don't need high availability Mongo, right? But in production, you most definitely do. So those sorts of things are things that you have to build in. So there's a common architecture out there. It's called a common cloud core, and it's the integration of 3 different technologies together: CMP, cloud management platforms, PaaS, platform as a service, and automation frameworks to come together and deliver this kind of functionality that we had in multi-tiered, but with a lot more change, a lot more permutations that you have in microservices. So let's understand a little bit on the differences between IT, the guys that are providing this, and developers. So here's the biggest change that we've seen over the last couple of years is developers need things quickly done, right? They need to iterate very quickly because they're in a highly competitive marketplace. And so what have they done? They went to the public cloud. Why? Because public cloud's easy, right? I can spin up 10 machines, 100 machines, whatever I want in a matter of minutes. Where if I go to IT, they say, well, it takes 3 to 4 months to get data center space and get the machine set up and then installed. Now, IT is doing a good job. They're trying to build up private clouds so that they can offer the same types of services as public cloud. And they still have to manage legacy as well. So these are some issues that they're trying to do. So we're starting to see the emergence of private cloud in the enterprise space, and IT is doing a pretty bang-up job getting there. But the problem is that public cloud's moving faster. So one of the dangers that we have that we want to make sure that we don't get stuck with is that developers get stuck with one public cloud and one public cloud service only. Then they have lock-in, they have vendor lock-in, which they don't want. So what we really want to do is we want to put a hybrid cloud in place. Even if it's a simple portal in place, that then the developer is not tied to specific services in the public cloud, but that they can take advantage of public and private cloud services through one interface. And if you have a good hybrid solution in there, then the developer doesn't even know which cloud they're actually running on. They'll be running just in the hybrid cloud. And IT will now have the opportunity through policies to redirect the services that they're asking for onto public or private, or maybe even tie into a legacy application. So good hybrid orchestrator is extremely important in getting to that point. So let's talk about environments real quick, because understanding environments will show how we can use a hybrid cloud to really understand and use these environment concepts differently. So let's take a look at what a local environment might look like for a simple Node.js application, right? So in this case, I'm using Node.js with worker nodes, and I'm using Redis as my message queue, a persistent message queue between my Node.js and my worker nodes, my business logic and worker nodes that are out there doing microservices. And I'm using MongoDB. So in this case, I have 4 services that are running, right? 2 of them are Node.js, 1 is a Redis service in Mongo. This easily fits on my laptop, and I can code pretty much the whole application on my laptop without a problem here. Now, if I were to move into maybe development cloud, now this could be in a public or private cloud, and it looks like it's the exact same. One Node.js, another worker node, Redis queue, and a MongoDB. And I could integrate other people's code in here. Maybe there's more worker nodes in here because another developer created some other microservices that I want to attach to. The key is that the environment definition is the same definition that I use in local. I just said I need Node.js, I have some worker nodes, I need Redis and Mongo. A developer, he doesn't really care whether it's on local or development, it should behave the same for him. Now comes something tricky, right? Because your automated CI/CD system is going to kick off, and it's going to start running a build and a test. So let's take a look at what the test cloud looks like. So a test cloud, you want to check and make sure that you have programmed your microservice appropriately and your application appropriately so that you can have multiple instances of the same Node.js business service and your worker services. You're going to have multiples of those. And now Redis, I'm going to have 2 Redis queues, making sure that I have a little bit of redundancy there and that I can talk. And I may even put a little redundancy in there for MongoDB. And I may even have another service that's watching and doing performance metering for me, right? Now, the key here is that the developer shouldn't have to have changed his definition for his application. It would still say Node.js, worker Node.js, Redis, and Mongo. But because the test environment knows that it's a test environment, it's going to fire off 2 Mongo instances, 2 Redis instances. It's automatically going to inject a performance metering tool in there, and it's going to know how to do these things on its own without the developer knowing. Now, if we take this even as a step further, then I have a staging area. And if you look at my staging area now I'm doing like UAT testing, user acceptance testing in my staging. I'm, trying things out, making sure that I can run in parallel with production. Now I have a load balancer on the front end of my Node.js and my web app. I got several message queues up there. I've got MongoDB running in high availability, and I've got even more Node.js servers running. Again, no change to the developer. He knows, hey, this is going to work. I did it on my laptop. It should work in staging. And then finally, I get to production. And this is where I lock down with security, and logging is dialed back only to the compliance levels that are needed. And again, no change from the developer. The key with this, as you can tell, is that the developer can focus on writing his code instead of debugging environments. But the question is then, who's going to debug the environments? So someone's got to do that work. So inside the Common Cloud Core, we can find a bunch of use cases and actors of these hybrid clouds, and we find out who actually should be responsible for those. And we can also see which tools can be leveraged to make these things happen. So one thing that we can look at, first off, the Common Cloud Core is an open architecture, and you can find it here at this URL, github.com, cade/c3/wiki has the full architecture there. It is an ongoing project. If you want to contribute, feel free to contribute. We're trying to capture a bunch of use cases and architectural elements to help make hybrid clouds easier to use. So the top three key actors of the Common Cloud Core are the operations manager, and this is your typical IT guy, but he is primarily responsible for creating policies, managing the clouds, and infrastructure, right? How is the infrastructure going to work? As you notice here, he's not really talking about the different environments, but he does work closely with another actor, which does work with the environments. He's just handling the infrastructure, security, capacity planning, managing users, and things like that. The next role is the application developer, which we've already kind of talked about. And his job is to write applications, debug them, and fix problems, and move them on. Again, no concept here of environment. That's an important concept, is environment. So who does this? You're probably thinking, well, DevOps. Well, I like to give a different name. I think DevOps is kind of does too much, and no one really appreciates them. They're doing some development and some operations. So let's give them a real name. Let's call them stack developers. Now, in this case, a stack developer is responsible for defining and designing services that can be reused across multiple application teams. Like, for example, Mongo or Redis or MySQL or any number of other services that might be available, Kafka, Hadoop, whatever it is. Their job is to create that service so that it can run both on a local box, in a dev cloud, in a test cloud, in staging areas, and in production. So working closely with the operations managers to know what the policies are that they need to adhere to, as well as working with the development teams to know which services are needed, that they can build up these service catalogs that can be used over and over again. And a really good hybrid cloud will have service catalogs. Some of them call them templates, some of them call them blueprints, but that they can use those to build up these great catalogs that will foster reuse in their application developer team. So the stack developer is a really important guy to have around. So that's it on introducing kind of the Common Cloud Core and what that means. Go ahead and check out, again, the Common Cloud Core wiki site on GitHub, where you can find out a lot more information about the Common Cloud Core, and look for more videos to talk about how to actually use Common Cloud Core concepts when you're developing in the cloud.